so back to front seat. So the channels come in two types. They come like that, and they come like that. See how that's on an angle? We call that tapered, and we call that parallel. And you're not going to forget that. That's a question in the test as well. So if you get that one, you go, yeah, I remember that from class, or if you're sleeping right now, you go, I remember Roger saying something like that. Okay, it's actually written a bit further on. If you go back here to what I skipped before, you'll see some of these things are written there, and this is how we call them up on the drawings. And this is how you need to call them up on your assignment. So, for example, a beam, we used to call it up by its height, by its width, and by its weight per metre. So 760 by 270 by 244 kilograms UB. UB standing for universal beam. Nowadays, in fact, probably since about the year 2000 or more, we call it up as a 760 UB 244. Why? Why would I be doing, why don't I just say universal beam, call it up as a 760 UB 244. Universal column, let's just call it up as 200 UC 60. Why have I bothered showing you how we used to do it back when the dinosaurs were on the planet? That's my nickname in the department, by the way. Used to be Little Dinosaur, but the big one's gone now. No one out for a half mark. Oh, he looks like he's got something going on. No. Blank. Okay, it's not that tricky, and I have actually asked you this question in somewhere, surveying, I think. In surveying, I put up a whole lot of things like chains and inches and feet, and asked you why I didn't make my notes. It's actually a very logical reason for this. I've probably done, of my 25 years in consultancy, before I did 20 years here, I've probably done about 4, 5, 6 years in structural. And of those 6 years, probably 80% of the work in Auckland was adding on to buildings. It was 20-30% of brand new buildings, yep, fair enough. That's easy, you're just using those call-ups, the new call-ups. But once you're adding on, say you're adding on to this building, you wouldn't just go, oh yeah, we'll just start drawing something on out here. If you're connecting to a building, you need to know what's there, so you need to go to council and get the old plans out. And the old plans will have those old call-ups up. And you've got to understand what the old call-up means, so you can convert it for your new drawing into the new call-up. Some of them are very different, some of them are fairly similar. It's a bit like when you're reading a plan with feet and inches, and you're going, what the heck? You know, we're in metres now, what's going on? You've got to be able to convert it as well. So I do get comments at the end of the year. I don't mind the horrible ones about my dress code or anything like that, or not having a shave in the morning. But then I get some ones that say, oh, and his notes are really old-fashioned. He's got these old-fashioned things there, and he needs to get modernised. But this is something that's really important. You do need to know these. Right? Once again, it's a question in the test. Hopefully, by missing out on the half mark, you'll, and by the way, the degrees didn't get that one either. So you'll notice that some of them are very similar. As we come down here to the plates, the plates are still called up as the width by the length by the thickness. We used to put the word PL to identify it as a plate, so you may see PLs all over the place in some of the old drawings, if you pick up an old drawing. So, how do we join these members together? Well, fun fact, the Auckland Harbour Bridge is made up of millions of rivets, and I think only last year, was it, or the year before, a truck crashed into the side and it caused all sorts of havoc because all the rivets popped, and they were wondering how they were going to fix it, because riveting is rarely used these days. It's not a skill that it's not something they do. You tend to do bolting or welding. And welding, of course, on site with all the cars going past is health and safety and all the rest. They had to close off 2 or 3 lanes, and they had to put all these plates on to brace it. So yeah, riveting goes back to the sort of 30s, 40s, 50s. That's how they used to do everything. Drill a hole, put the rivet through, and a rivet gun which would pull the back of the rivet up against the back of the steel. The problem with that is it created weak points where there were areas of rust. So obviously bridges over salt water had a problem. So the fun fact is it takes a year to paint the Auckland Harbour Bridge with rust inhibitor paint, and they get to one end and they high-five each other and they start again and start painting it all the way back again. They actually painters there 24/7, well I don't know 24/7, but they're there for a whole year painting the bridge. And in San Francisco, some of you may have heard of the Golden Gates Bridge. It's a brown, sort of orangey, bit of a yucky colour. The chief engineer realised he'd blown his budget towards the end of the bridge, and they came up to buying the paint. And he said to the mayor at the time, hey, it's going to cost us too much to keep painting this every year. He said, however, if we put the rust inhibiting, the orange stuff straight on, it'll last longer. You won't have to paint it every year, every 5 years or something like that. It'll save the city millions. And the mayor said, don't worry about that, I'll sell it to the people. So it's interesting that the chap that's just walked in, the exact colour of the bridge, so I was laughing at. The jersey that he's wearing. So we're talking about the Golden Gates Bridge in San Francisco. And anyway, this horrible, oh sorry, no offence, this brown colour, you wish you walked in late, eh? Everyone else is going, not going to walk in late for Roger's class. This brown colour, he took it to the people and he said, well, the landscape in the background was an orangey brown,